America, a land of vast landscapes and natural wonders, has recently found itself facing the unsettling power of earthquakes. These natural phenomena, while not uncommon, have taken many by surprise due to their sudden and unpredictable nature. In a series of events that have rattled nerves and captured headlines, multiple earthquakes have struck different parts of the country, causing widespread concern and prompting immediate responses from emergency services, leaving many to wonder about the causes and consequences of these tremors. The aftermath of these quakes has left communities grappling with damage and uncertainty, as they seek to understand the full impact on their lives and infrastructure. From the heart of Texas to the Pacific Northwest, the ground has shifted, reminding us of the powerful forces at play beneath our feet. These regions, though geographically diverse, share a common vulnerability to seismic activity. These recent events serve as a stark reminder that no corner of the United States is entirely immune to the threat of earthquakes. The shaking buildings and infrastructure underscore the need for robust preparedness measures. While some regions are more prone to seismic activity than others, the recent tremors in Texas, Oregon, and Washington highlight the unpredictable nature of these events. Even areas not traditionally known for earthquakes are experiencing these unsettling shifts. This string of earthquakes has sparked concern and raised questions about the science behind these tremors, the potential risks they pose, and the steps we can take to prepare for the future. Experts are delving into data, seeking patterns and explanations. As we delve deeper into the details of these earthquakes, we'll explore the scientific principles that govern seismic activity, including the intricate movements and interactions of the Earth's crust. The role of tectonic plates, which are massive slabs of rock that make up the Earth's surface and whose movements are responsible for most earthquakes, and the potential influence of human activities. Practices such as fracking and large-scale construction can sometimes trigger seismic events, adding another layer of complexity to our understanding. We'll also examine the history of earthquakes in the United States, looking back at significant events that have shaped our current knowledge and preparedness strategies. The risks associated with these events, which can range from structural damage to loss of life, and the ongoing efforts to mitigate these risks through better building practices and early warning systems, and the importance of preparedness. Community drills and emergency supply kits are crucial in ensuring that individuals and families are ready to respond when an earthquake strikes. By understanding the forces at play, we can better equip ourselves to face the challenges posed by earthquakes and build more resilient communities. Through education, preparation, and innovation, we can reduce the impact of these natural disasters and safeguard our future. The recent earthquakes in Texas, Oregon, and Washington provide a sobering illustration of the widespread nature of seismic activity. These events have captured the attention of scientists and residents alike, highlighting the need for increased awareness and preparedness. Each quake, though occurring in different geological contexts, serves as a reminder that the Earth's crust is in constant motion. The shifting of tectonic plates beneath our feet is a continuous process that can lead to sudden and sometimes devastating consequences. In Texas, a series of earthquakes, some registering as high as 5.0 on the Richter scale, have rattled the western part of the state, particularly around the Permian Basin. This region, known for its rich oil and gas reserves, has experienced an uptick in seismic activity in recent years. Residents reported feeling shaking and swaying, and some minor structural damage was reported. The community's response to these tremors has been one of concern and vigilance, as they adapt to the new normal of living in an earthquake-prone area. The proximity of these quakes to areas with significant oil and gas activity has fueled speculation about a possible connection between the two. Some experts suggest that the process of hydraulic fracturing, or fracking, may be contributing to the increased seismic activity. Meanwhile, in the Pacific Northwest, earthquakes are a more familiar threat, as the region sits atop the seismically active Cascadia subduction zone. This area is known for its potential to produce massive earthquakes that could have far-reaching impacts. A series of smaller earthquakes, ranging in magnitude from 3.0 to 4.5, were recorded off the coasts of Oregon and Washington. These quakes, while not as powerful as those in Texas, still serve as a stark reminder of the region's seismic activity. While these tremors were not as powerful as the ones in Texas, they serve as a reminder of the region's vulnerability to much larger earthquakes. Communities along the coast are continually preparing for the possibility of a major seismic event. These recent events, though separated by geography and geological context, underscore the importance of understanding and preparing for earthquakes. The need for comprehensive preparedness plans and public education on earthquake safety cannot be overstated. While the science behind these events can be complex, it's crucial to grasp the basics of plate tectonics and the factors that contribute to seismic activity. Understanding these natural processes helps us to better predict and mitigate the effects of earthquakes. By understanding the forces at play, we can better assess risks, implement preventive measures, and build a safer future for all. Investing in earthquake-resistant infrastructure and community education programs is essential for minimizing the impact of future seismic events. To truly grasp the significance of recent seismic events, we must delve beneath the surface and explore the fundamental science behind earthquakes. At the heart of this understanding lies the concept of plate tectonics, a theory that revolutionized our understanding of the Earth's structure and behavior. The Earth's outer layer, known as the lithosphere, is not a single solid shell. Instead, it's broken into numerous massive pieces called tectonic plates. These plates, constantly in motion, float atop a hotter, more fluid layer of the Earth's mantle. This movement, driven by heat from the Earth's core, causes the plates to interact in various ways, leading to the geological phenomena we experience on the surface, including earthquakes. When tectonic plates collide, pull apart, or grind against each other, immense pressure builds up along their boundaries. This pressure, if exceeding the strength of the rocks, is suddenly released in the form of seismic waves that radiate outwards from the point of rupture, known as the earthquake's focus. These waves cause the ground to shake, creating the tremors we experience as earthquakes. The magnitude of an earthquake, measured on scales like the Richter scale, reflects the amount of energy released during this rupture. The recent earthquakes off the coasts of Oregon and Washington draw attention to a particularly seismically active region, the Cascadia subduction zone. This 600-mile-long fault, stretching from Northern California to British Columbia, represents a convergent zone where the Juan de Fuca plate is slowly sliding beneath the North American plate. This process, known as subduction, is a major driver of earthquakes and volcanic activity in the region. The Cascadia subduction zone has a long history of producing powerful earthquakes. Geological evidence suggests that the zone has experienced at least 4 major earthquakes in the past 10,000 years, with the last one occurring in 1700. This earthquake, estimated to have a magnitude between 8.7 and 9.2, was so powerful that it generated a tsunami that reached the coast of Japan. The ongoing subduction process at the Cascadia subduction zone makes the region a prime candidate for future earthquakes, including potentially catastrophic ones. Scientists estimate that there is a significant chance of a major earthquake occurring along this fault in the next 50 years. The potential consequences of such an event are enormous, with the potential for widespread damage, tsunamis, and loss of life. While the earthquakes in the Pacific Northwest are largely attributed to natural tectonic processes, the recent tremors in Texas have sparked debate about the potential role of human activities, particularly oil and gas extraction, in triggering seismic events. The rapid increase in oil and gas production in the Permian Basin has coincided with a surge in earthquake activity, raising concerns about a possible link. One suspected culprit is the process of hydraulic fracturing, commonly known as fracking. This technique involves injecting high-pressure fluids into underground rock formations to release trapped oil and gas. While fracking itself may not directly cause large earthquakes, scientists believe that the disposal of wastewater, a byproduct of fracking and conventional oil and gas extraction, could be a contributing factor. This wastewater, often containing a cocktail of chemicals and naturally occurring radioactive materials, is typically injected deep underground into disposal wells. These injections can increase pressure along fault lines, potentially triggering earthquakes, especially in areas already prone to seismic activity. The volume of wastewater injection in the Permian Basin has skyrocketed in recent years, raising concerns about its potential impact on seismic stability. The recent earthquakes in the United States, while unsettling, are not isolated incidents. They are part of a much larger and complex seismic history that has shaped the nation over centuries. America has a long and tumultuous history with earthquakes. some of which have left an indelible mark on the nation's landscape and psyche. From the East Coast to the West, no region is entirely immune to the forces of nature. These past events serve as a stark reminder of the destructive power of earthquakes and the importance of preparedness. Communities have learned, often the hard way, that readiness can make a significant difference in survival and recovery. One of the most significant earthquakes in U.S. history struck San Francisco in 1906. This catastrophic event is etched in the annals of American history. With an estimated magnitude of 7.9, the earthquake and subsequent fires devastated the city, killing thousands and destroying much of its infrastructure. The fires that followed the quake were almost as destructive as the quake itself. The San Francisco earthquake remains a defining moment in the city's history, shaping its urban planning, building codes, and disaster preparedness strategies. The lessons learned from this disaster have influenced earthquake readiness across the country. Another notable earthquake struck Alaska in 1964. This event, known as the Great Alaska Earthquake, was a monumental natural disaster. The Great Alaska Earthquake, with a magnitude of 9.2, was the most powerful earthquake ever recorded in North America. Its sheer force was felt across vast distances, causing unprecedented destruction. The quake caused widespread damage, triggering landslides, tsunamis, and altering the elevation of some coastal areas. The aftermath was a stark reminder of nature's unpredictable and formidable power. These historical events, along with countless others, underscore the ever-present threat of earthquakes in the United States. From California to the New Madrid seismic zone, the potential for future quakes is a constant concern. By learning from the past, studying the science of earthquakes, and implementing effective mitigation strategies, we can work towards mitigating the risks and building more resilient communities. The ongoing efforts of scientists, engineers,